Hi, this is Mrs. Holbrook again with a basic STEM algebra review solving multiple step equations. Inverse relationships. How do we undo the operations being done? An inverse basically is that it undoes what they do. So if they add, you subtract. If they subtract, you add. If they're multiplying x or your variable by something, you need to divide by that number. If they're dividing, you multiply. If they square something, you need to take the square root. If they take the square root of something, you need to square it. This works for cube roots and cubes as well, for an inverse relationship. You need to work to peel everything away from the variable. So again, the variable needs to be alone. Now here's an example that I think you guys need to keep in mind. And let's see if I have my ink working here. If they multiply by a fraction, use the inverse fraction but still multiply. So an example, the fraction 2/3 and the inverse 3/2. If you multiply fractions, if you remember, you just multiply straight across. So 2 times 3 is 6, 3 times 2 is 6. So it becomes a 1, which basically in math just makes it disappear. You don't see multiply by 1 written out anywhere. Same thing with 7/8 and 8/7. When you multiply, you get 56 over 56. Bigger number, but it's still just a 1. So that's how you can get rid of those ugly fractions when they show up. So some examples, and again, these are multiple step equations, so there's going to be more than one thing to do. Here's our x that we're trying to get alone. And if we look, the 5 is attached very closely to it. So we're going to save this for our last step. We're going to peel away the easier stuff first. So since they add 3, we are going to subtract 3 from each side. So we have 5x, and then 3 minus 3 is 0, so we don't even need to think about that, equals 20. They're multiplying, so we divide. 5 divided by 5, there's another one of those ones that show up. So x equals 20 divided by 5 is 4. Now we can check that if we want to, and I don't always make students do that, but if you want to know if your answer is correct, we're looking to see is 5 times 4 plus 3, 23. Well, 5 times 4 is 20. 20 plus 3, sure enough, is the 23. So it does work out, and we have the right answer. Okay, number 2, we have 5 plus x over 4 equals 1. Again, here's our x. This divide by 4 is attached to it very closely. So we're going to move a little further away, and we're going to subtract 5 first. Now, a lot of people want to make sure that they do things on both sides of the equation. Remember, what you do to one side, you have to do to the other. So they'll draw a line, and that was the straightest line I could do on this tablet. They draw a line right through the equal sign so that they can make sure that I did it on this side and now I did it on that side. So we subtract 5 from each side. 5 minus 5 is 0, so I don't even need to write that. So we have x over 4 equals 1 minus 5 is negative 4. Well, x over 4, what's this really mean? Well, this really means divide. So we're going to multiply each side by 4. And I showed it there, and I showed it over there. So 4 divided by 4, there's another 1. So I don't need to see it anymore. So x equals negative 4 times 4 is negative 16. So x equals negative 16. Again, if we want to check it, we can. 5 plus, instead of x, we're going to write our negative 16 over 4 equals 1. Well, 5 plus negative 4 equals 1. 1 equals 1. It works. A couple more examples. 4/5 m plus 2 equals 6. Now I've got that ugly fraction, and that's usually what I want to start with, but since this plus 2 is still kind of floating out there all nice and easy by itself, we're going to subtract that from each side first. So we end up with 4/5 m, this is a 0, equals 6 minus 2 is 4. Well, again, they're multiplying by a fraction, so I'm going to multiply by the inverse of that fraction. So 5 times 4 is 20, 4 times 5 is 20, or it just becomes a big fancy 1. So m equals, now 4 times 5 is 20, and it's over 4, which is 5. So m equals 5. Now we can check that. 4/5 times 5 plus 2 equals 6. Well, 4/5 times 5, again, we can almost look at this as 5 over 1 and multiply straight across. So you get 20/5 plus 2 equals 6. Well, 20 divided by 5 is 4, plus 2 is 6. Is 4 plus 2 6? Yep. So I should write that a little neater. M equals 5. That way my teacher, me, can find it a little bit easier. Sometimes finding your answers in your work is like a scavenger hunt for me. So m equals 5. Now in this example, the whole numerator b plus 1 is divided by 3. There's nothing else floating around that looks easy to undo. So I need to take this whole piece and multiply it by 3. And then I need to take this whole side and multiply it by 3. And again, just as an example, I'm going to go ahead and draw my bar to split my work. So 3 divided by 3 is now 1. And I'm left with b plus 1 equals 2 times 3 is 6. Well, this looks a whole lot easier to work with. Now we need to finish peeling things away from b. So we subtract 1 from each side. Sorry, now it's joining lines a little weird. So 1 minus 1 is 0, so I have just b over here. And then 6 minus 1 is 5. Apparently they like the answer 5 in these examples. So I have the solution b equals 5. If I want to check that, I can place 5 where the b is, plus 1. And remember we divided that by 3 equals 2. Well, 5 plus 1 is 6. I'm sorry, I don't know why it's joining lines like that. 6 divided by 3 equals, I'm so sorry, equals 2. Alright, now it's going to drive me crazy. Well, 6 divided by 3 is 2, and 2 equals 2. So my answer truly is b equals 5. Alright, we're almost done. I know I've gone on for a little while here. But let's look at writing equations. Twice a number plus 4 equals 6. What is the number? Well, twice, that's the number 2. Twice a number, that tells me I'm multiplying that number, plus 4 equals 6. There's my equation. Now I just need to solve it. So we subtract 4 from each side. 2n equals 2. Divide each by 2, and n equals 1. So in this case, any question like this on an accuracy assignment or a test is going to be worth at least 2 points. Because I'm looking for 2 pieces. I'm looking for the equation and I'm looking for the answer. Find 3 consecutive integers whose sum is 36. Now, consecutive integers means that they're in a row. 1, 2, 3, 4, 5, 6, 7, 8. They're consecutive. So if I look at a couple numbers, let's just do, 4, 5, and 6. If I called this n, how much more is 5? Well, 5 is 4, my n, plus 1. Well, compared to the 4, how much more is 6? 6 would be n plus 2 more, right? Now remember, we called 4 n. So they want 3 consecutive integers whose sum is 36. So our 3 consecutive numbers looks like this. N plus 1 plus n plus 2. 3 numbers in a row. There's 1, 2, 3. And I have them right here. 1, 2, 3. And in this case, their sum is 36. So when I add them all up, it's 36. Now don't let this 4, 5, and 6 confuse you. It was just there as an example to show you how I came up with n plus 1, and n plus 2. Let's combine like terms. 1, 2, 3n plus 1 plus 2 is 3 equals 36. Subtract 3. Subtract 3. 3n, this is gone, equals 33. Divide by 3. And n equals 11. Is that my answer? Nope. So my answer is 11. 11 plus 1, 12. 11 plus 2, 13. So here are the 2 pieces that I'm looking for in that example. And for some reason, this book series really likes these consecutive number problems. All right. Hey, it left that circle there. I don't know why. All right, so here is your turn. Here is what you need to practice. Sure, it's not going to let me erase it. All right, whatever. Go away. All right, try these before class. Solve for V in number 1. Solve for A in number 2. Solve for Z in number 3. Try the story problem or the writing an equation for number 4. Okay, sorry, I thought it stopped recording for a second, but it looks like it's still going. So number 4 says 16 is 7 plus 3 times a number, find the number. So we need an equation and the answer. And then number 5 says find 2 consecutive integers whose sum is 35. And I'm sorry about the little circle there. Okay, good luck, and I'll see you in class.